This is a video to support your work with the homework for this weekend. I know it's a lot, but this is almost the second to the last push for review, comprehensive review for the STAR exam. Okay, the first set of problem will ask you to do absolute value equation. So what you do there is to isolate this absolute value expression. So we need to get rid of two things here. We need to get rid of the 2 here, and we also need to get rid of that negative there. Okay, so we're going to take 2 more steps before we actually solve completely. So let's take the steps. So the first thing I will do is to subtract 2 from both sides. That will leave me with x plus 2 equals -8. So now we're going to get rid of this negative. So divide every side by -1. So by -1, that will cancel that. And you have x plus 2 equals 8. So if you remember what we did in class, if it's absolute value, you have to set it to plus or minus. So it will be x plus 2 equals plus minus 8, which we can break into 2 as x plus 2 equals 8 or x plus 2 equals -8. If you subtract 2 from both sides, s equals 6. Subtract it from both sides, s equals -10, which actually makes sense, because if you look at the left side alone, this absolute value equation, a function has been shifted to the left, reflected across the x-axis. See reflection across the x-axis, and then shifted 2 up. So if you do that, you're not required to do this, just to explain something to you here. That is 2 to the left and 2 up, and then reflected across the x-axis. And then if you plot it, it will look something like this. And then we want to know where this is equal to -6. So you draw the line -6, 1 2 3 4 5 6, and you draw that line. You will see the intersection will be somewhere over here at 6, and somewhere over here at -10. So basically that's what it is all about. All right, the next set of problem has to do with variation. In this example, you have P and Q varies inversely. All right, so that means that the product P times Q must be equal to a constant number. How do we find that number? We are given an initial value of P and Q. So when you multiply 24 times 2, you will get 48. Okay, so if you multiply here, you get 48. Now that means P times Q is always 48. So now if you are given P to be 8, so that means 8 times Q equals 48. So now we are going to divide both sides by 8. If you divide by 8, you get Q equals 6. So now we know Q is actually equal to 6. All right, so that's what you do when you are given a problem like that. And now here is another example. So this one has to do with building a house. The number of days D that is required varies inversely with the number of workers, so which makes sense. So the more workers you use, the less the number of days it takes you to finish it. So we know this is inverse variation. That means if you multiply days times W, you always get a constant number. How do we know the number? We are given 12 and 43, which if you multiply them together, you will get 12 times 43. 12 times 43 will give me 516. So that's the first condition you're going to write down. So now we know if you're given 3 workers now, so we're going to say 3 times the number of days will give me 516, then divide by 3, so number of days will just be 172 days. So which makes perfect sense, because as the number of our workers decrease, the number of days go up. All right, now we go to the next set of problems you're going to see tonight. It's going to be this. Here we go back to finding inverse again, but with this time with exponents. Okay, so we are given an exponential function, so we write it as y equals 7 to the power of x divided by 5 minus 10. So if you remember what we did way back, to find inverse we switch x and y. X equals 7 to the power of y divided by 5 minus 10, which you are going to add 10 to both sides, and then you have 7 to the power of y divided by 5, and then the next thing is to multiply both sides by 5. So 5 times x plus 10 equals 7 to the power of y, and then we can take log of both sides. So log base 7 of 5 times x plus 10 will give you y. So which you write it as inverse, and the correct answer there will be this one, letter C. All right. The next sort of problem you're going to do. Okay, this one involves e. This one is just like ordinary base. So you're basically going to do the same thing, right? As y equals 4e to the power of x to the power of 1/2, all divided by 5. Switch x and y. And then multiply both sides by 5 to get rid of the 5. And then you will do, I want to get rid of the half, so I square both sides. Square both sides. The half and the square is going to go away. So you're going to have, you're going to have e to the power of y. 4 times e to the power of y equals this. By now you can guess what we're going to do next, which is dividing by 4. And then you're going to have 5x squared divided by 4 is e to the power of y. And of course the last step is to take the ln of both sides. So if you take ln of both sides, it will be ln of this quantity all divided by 4 will give you your y, and that is answer choice number, the last one. Okay, that's the last one. And then there's another kind of problem where you have to graph. You have to graph this problem. So here is the example given here. You will recognize that this is an exponential function. Okay, it's an exponential function, and so if you graph the parent function of exponential function, looks like this. Here is the parent. Okay, if you notice that this has this asymptote, I want to draw in red. The asymptote is horizontal. So when you go here and select, it will be horizontal. You're going to type in there because it's horizontal asymptote. Okay, and then now it asks you to graph 2 points. So, well, of course you have to draw. You have to use horizontal asymptote. Okay, good. Now we're going to find where is the location of the asymptote. Notice that this graph has been shifted down by 1. So that means the asymptote is actually shifted down by 1. So when you drag on your screen, you must drag the horizontal line to look like this. That horizontal line must come up like that from wherever it is. Okay, then the last thing is to graph 2 points. To graph 2 points, what you need to do is to select your x value carefully. Here is given to us as x minus 1 minus 1 as your y. So we can just select numbers that will give me whole number. So we can do guess and check. If we put 0 for x, then you're going to have 4 to the power of negative 1, which is 1/4. That's not a whole number. Let's go to the next one. What if I select 1? 4 to the power of 1 minus 1 minus 1 will be 4 to the power of 0 minus 1. And then 4 to the power of 0 is 1. 1 minus 1 is 0. Okay, that's a good point because we selected x to be 1. So 1, 0 is a good point. Okay, let's go to another point like 2. Let's try 2 now. So 4 to the power of 2 minus 1 minus 1. 2 minus 1 is 1. 4 to the power of 1 minus 1. And 4 to the power of 1 is 4. 4 minus 1 is 3. So when x is 2, y is 3. So another point will be 2, 3. So we're done. So when you go to your screen, you need to drag these yellow points, drag them to, one of them is already at 1, 0. We just need to drag this one and bring it to 2, 3. 2, 3 will be like over here, 2, 3. No, like that. Sorry about that. We're going to drag that point to 2, 3 over here. So it's going to be over here. So when you draw the graph, the computer will draw the graph for you. It's going to draw the graph like this. It's going to through that point and then go up that way. And that will be the solution to that. So you might also get one that is not, or it's not exponential, but it's logarithm. You're going to use your knowledge of the parent function to do the logarithm. Okay, so you know from parent function that logarithm goes like this. It goes like this. Okay, now let's examine this equation. Examine this equation now. We see that, well, we have to rewrite the inside. See, let's just go back here. See, the inside function here, expression is not in order. It's mixed up. So we need to rewrite it like this, like so. It will be -3 log base e negative parentheses x minus 6 and then minus 5. So that tells us that this parent function is going to shift 6 units to the right, reflect across the y-axis, and also reflect across the x-axis. So reflect across the y-axis, reflect across the x-axis, and then shift down by 5. It's a lot of information going on there with this parent function. So shift down by 5 after moving 6 to the right. Okay, so let's start moving 6 to the right. Well, we are not going to, when you are going to move to the right, you are going to move the asymptote. Remember, the asymptote originally is over here. This is the asymptote. Write down the line. Asymptote. So if we move it 6 to the right, it's going to move, this red line is going to move 1, 2, 3, 4, 5, 6, somewhere over there. So the new graph will look something like this. Okay, so the asymptote will be given to you somewhere on the screen. You're going to drag it to x equals 6, like over here, x equals 6. So that will be your asymptote. So you notice that before we dragged the asymptote, horizontal asymptote, when it was exponential, but if it's log, we drag the vertical asymptote to whatever the movement is. Okay, so we've taken care of that already. That's done. The next thing is we're going to pick 2 points. We're going to pick 2 points. Let's use the information given to us to pick 2 points. Okay, I'll remove this. I'll go back over here. All right, your goal is to make sure you don't have log with a negative number. Okay, you want a log that will be a power of 3. Let me go back and zoom in on this. Okay, you see how this, I take attendance quick. You see how this is log base 3, right? So whatever that is inside this parenthesis has to be a power of 3. We want it to be a power of 3 because then we're going to have whole numbers. So remember, all the powers of 3 are like this. You have 3 to the power of 1, 3 to the power of 0 is 1, 3 to the power of 1 is 3, 3 to the power of 2 is 9, 3 to the power of 3 is 27. Let's stop right there. So we want this stuff inside the parentheses to be one of those numbers. So what we can do is to set it equal to that. So we can set each of these equal to any of these numbers. So let's say we set it equal to 1, for example, to 1. So we're going to say negative x plus 6 must be 1. and then negative x equals negative 5 when you subtract this from both sides, and then x equals 5 if you divide by negative 1. Let's see if it works. So let's see, if I put 5 here, so it will be negative 5 plus 6, which is 1, which makes sense. Okay, so now we succeeded in getting this to be 1 by setting x to be 5. So then, what is log base 3 of 1? Of course, everybody knows it's 0 because 3 to the power of 0 is 1. Okay, right? So all this log expression, if x is 5, becomes 0. So log base 3 of 1 is 0, right? And then we multiply by negative 3. 0 times negative 3 is 0. And then we subtract 5. So let me write them in order so you don't get confused. It looks like this. So we're going to have negative 3 times the 0 minus 5. Remember, this 0 is this stuff that I'm highlighting in yellow. All this is 0 when x is 5, okay? It's going to make sense to you when you practice some more, okay? So now we have that. And then we can do is negative 5. Now we got a point. We got one of our point. When x is 5, y is negative 5. Okay, good. 1 point. We need one more point. So let's go back and do the same thing all over again. We want this stuff that's inside to be equal to 3. We want it to be equal to 3. All right, so let's try to write an equation for that. It will be negative x plus 6 equals 3. And so subtract 6, negative x equals negative 3. And x equals 3. Okay, so let's see. If we put 3 here, it will be negative 3 plus 6, which is 3. So we got it. So we're going to have to rewrite it like this. We're going to rewrite it like this as negative 3 log times log base 3 of 3 minus 5. Okay, so log base 3 of 3 is 1. So negative 3 times 1 minus 5. Negative 3 times 1 is negative 3. Minus 5 is negative 8. So now the second point will be when x equals 3, y equals negative 8. So we got the 2 points. It's a lot of work, but that's how you analyze log graphs. So now you're going to drag this point to 5, negative 5. 5, negative 5 will be over here. And then the other one will be 3, negative 8. 3, negative 8 will be over here. Okay. So now what is left is to draw this graph. The computer will draw the graph for you like this. It's going to draw the graph for you like that. Which makes sense because it's reflecting across both x and y. It's getting vertical stretch by 3. And it's shifting down by 5. And moving to the right by 6. It's a lot of transformation, okay? The last set of problem is the one that will ask you to do multiplication or division of rational expression. So the first step to do there is to factor. We're going to factor each of the given expression. We're going to factor x minus 9 to be x minus 3, x plus 3. That's this part. And then divided by x plus 3. Okay, we're just factoring basically. And we'll factor this to be, now you see this one has to be taken out. X cubed and x to the 4th. X cubed is the biggest number we can take out from there. So they're going to take it out. X cubed. And then we'll be left with x plus 9. We factor the denominator. So this is negative 27. We know that 9 times 3 is 27. So the 9 is bigger. So x plus 9. And then x minus 3. Okay, now this is a multiplication. We don't need to do anything, but we need just to cancel out factors that are similar, that is exactly the same from the top and the bottom. So we're going to cancel out these factors. This is going to cancel out that. This is going to cancel out that. And this is going to cancel out that. And then we write what is left. At the top will just be s cubed. And at the bottom is just nothing. It's 1 really. It's 1, but which is just s cubed. This is what you're going to type into that box. The very last problem. This is a very long video, but you have to endure it. This is the last problem. This time we're dividing. So the first thing to do is to switch the division to multiplication. So it will look like this. 8x minus 48. You can tell that I'm a little bit tired. My voice is going down. But I'm going to hang in there until the video is done. I'm so tired. Alright, well, we're going to finish. Okay, you can see that I just swap this, switched around. Okay, switched around. That's what you do when you change division to multiplication, okay? So that it looks like the first problem. See how the first problem is? Now we've changed it to look like the first problem. And so now we just do exactly what we just did during the first problem. In the first problem, let's do it. So 8 is common here. We take it out. So x minus 6 is going to be left. X minus 6 is going to be left. Okay. And then down here, s cubed is common. And then x plus 2 will be left. X minus 7. X plus 7. That's the 49 there. And then x minus 6. No, x plus 7. And then x minus 6. I'm just assuming you know how to factor. If you are not sure, pause the video, go try how to factor each of this, and then come back to check that the answer is correct, okay? Now, we're ready to cancel because we already flipped it, so we're going to cancel all the common factors. This is gone. This is going to go with that, x minus 6. Let's see what is left that can go away. We can only cancel one time, okay? Absolutely, there's nothing left to cancel. We just need to write what is left, which is going to be 8 parentheses x minus 7 and then s squared x plus 2. That is what you're going to type in the box. I know the video is long, but you see, you're going to just scroll to the place you need and watch whatever part you need and then forget about the rest. I hope it helps you.